Hello to my fellow student, and especially to you, ma'am. Good day. My name is Jillian Bosho, and I'm the one who discussed this topic. So for today's topic that I'm going to talk is all about the introduction to ocean acidification. What is ocean acidification? So, when we talk ocean acidification, is the ongoing decrease in the pH value of the Earth's oceans. It caused by the uptake of carbon dioxide from the atmosphere. Ocean acidification is one of the several effects of climate change on ocean. The concern with ocean acidification is that it can lead to the decreased production of the shellfish and other aquatic life. Ocean acidification also often described as the evil twin of climate change. It also reduces the amount of carbonate, a key building block in the seawater. Oceans play a critical role in global carbon cycle by absorbing about a quarter of CO2 emitted to the atmosphere from human activities. CO2 emission, the acidity of the world's ocean. It affects marine plants and animals, especially those require calcium carbonate to grow and survive, and other species that rely on this for food. CO2 and ocean chemistry. Ocean absorb 1/4 of CO2 from the atmosphere. The CO2 would otherwise have accumulated in the atmosphere by leading to a greater climate change. However, the absorption of this CO2 has affected on ocean chemistry. Ocean or slightly alkaline, it could be more acidic. The average pH of oceanic surface water has been lowered by 0.1 units since the pre-industrial period. This represents a 30% increase in hydrogen ion activity. So, let us take a look on the diagram. As we can see, a CO2 is absorbed by the atmosphere with the seawater forming carbonic acid. This acid will release a bicarbonate ion and a hydrogen ion. The hydrogen ion bonds with free carbonate ions in the water, forming another bicarbonate ion. This free carbonate would otherwise be available to marine animals for making calcium carbonate, shells, and skeletons. The impact of ocean acidification. Biological processes affected by ocean acidification. Increasing acidity combined with other environmental stressors like increasing ocean temperature and pollution has the potential to affect many biological processes such as building shells, maintaining metabolism, boosting photosynthesis, obtaining essential minerals and nutrients. First is building shells. So when we talk building shells, many of animals and some algae use carbonate ions to make calcium carbonate shells and skeletons. On the other hand, ocean acidification, bicarbonate, some of organisms did the work harder to produce shells. So the second is maintaining metabolism. Many physiological processes operate within the pH range. Outside that pH range, there are biochemical reaction, maybe too slow or inefficient to keep the organism healthy. Species can adjust to changes in their surrounding by actively maintaining a constant internal environment. This maintenance also requires a significant expenditure of energy. The third one is boosting photosynthesis. Carbon dioxide can stimulate plant growth by boosting the rate of photosynthesis. Growth of seagrasses under the elevated carbon dioxide condition. Seagrasses provide valuable habitat, but if this is plant overgrow, it reduces the ecosystem biodiversity. The last one, but not the least, obtaining essential minerals and nutrients. Ocean acidification could make it harder for marine organisms to absorb nitrogen, phosphorus, iron, and other elements essential for growth. For example, when seawaters become more acidic, the ion attaches to organic compound. We should to prevent marine life from using these essential elements. Causes of ocean acidification. So first one is the burning of fossil fuels. Next, increase in the concentration of carbon dioxide in the ocean. The third one is industrial revolution leading to an increase in pollution. The fourth is increase in atmospheric carbon dioxide concentration. Fifth, the loss of biodiversity. Next, increase in concentration of due to chemical reaction. Next, lack of eco-friendly laws and regulation. The last one is a decrease in carbon ions. For ocean acidification. The first one is sea urchin and oyster larvae will not develop properly when acidity is increased. The second one, fish larvae lose their ability to smell and avoid predators. The effects of ocean acidification. First, loss of coral reefs. Second, loss of marine plants. Third, loss of marine animals. Fourth, loss of biodiversity. Fifth, loss disturbance in the food chain. Sixth, decrease in the local economy due to lack of fish and other marine products. The last is decline in tourism. Solution of ocean acidification. First is reducing the use of fossil fuels. Second, increasing the use of eco-friendly fuels. Third, use of technology for reducing pollution. Fourth, making strict regulation. Fifth, spreading the awareness to the masses. Sixth, promotion of environmentally friendly initiatives. The last one is the use of engineering. That's all part of my discussion. So let's move on to the next topic.
Good day everyone. I'm Guerrero Halisa and I was assigned to report the acidification effects on organisms, affecting life cycle of marine organisms, particularly at the lower end of food chain. Difficult for marine organisms such as coral and some plankton to form their shell and skeleton, and existing shell may be dissolved, already impacting many ocean species, especially organisms like oyster and coral that make hard shell and skeleton by combining calcium and carbonate from seawater. Therefore, acidification affects the life cycle of marine organisms, particularly the lower end of food chain. Due to acidification, marine organisms such as coral and some planktons experience difficulty in forming their shell and skeletons. Marine organisms work harder to produce hard shell and skeleton using the carbonate ions or calcium carbonate from seawater. The impact of ocean acidification are not uniform across all species. Algae and seagrass may benefit from higher CO2 conditions in the ocean, as they require CO2 for photosynthesis just like plants on land. More acidic environment will harm other marine species such as mollusks and corals and some varieties of plankton. Juvenile fish may have troubled location, suitable habitat to live. So, the impact of acidification are not uniform across all species. Example, algae and seagrass may benefit carbon dioxide as they need carbon dioxide for photosynthesis, just like plants on land. Acidic environment will harm other marine species such as mollusks, corals, and some varieties of plankton. Self-explanatory where jumbidil fish may trouble location suitable habitat to live. Animals that produce calcium carbonate structures have to spend extra energy either repairing their damaged shells or thickening them to survive. The animals that produce calcium carbonate needs extra energy in repairing the damaged shell or thickening them to survive. In more acidic water, the ability of the clownfish to detect predator was decreased. In locating suitable habitat for larval clownfish was affected by decreased pH levels, effect on shellfish, corals, and other calcifiers. First, let's identify first what is calcifiers. Calcifiers, organisms with shells or skeletons made from calcium carbonate. Calcium carbonate are among the most abundant forms of marine life. Ocean acidification decreases the ability of carbonate ions, dissolving pteropod cells. Neurological effects, dissolving theropod's shell. Tiny sea snail called theropods. Despite their small size, theropods are an important source of food for many species including fish, shells, and whales. But theropods have delicate calcium carbonate shells that are vulnerable to ocean acidification. Another name of tiny sea snail is called theropods, an important source of food for many species including fish, seals, and whales. Neurological effects. Ocean acidification can affect fishes' sense of smell and alter their behavior. But in more acidic conditions, young clownfish loses the ability to navigate home using their sense of smell. Mitigation. Combating acidification requires reducing carbon dioxide emission and improving the health of the ocean, creating marine protected areas, stopping destructive fishing practices, addition of alkali to the oceans, adding of limestone carbonate materials, plantation of trees, grain built around the industries. The ocean capacity of carbon store house is diminishing due to the ocean acidification. If nothing is done to help curb ocean acidification, its negative impact may be felt on marine environment, local communities, and all the way up through global economy.